The warm-up for today's lesson is really part of the lesson. So we're going to start with the warm-up. The students would have seen this, and it really gets us started with talking about some strange inequalities. Now, what do I mean by a strange inequality? Well, honestly, something that may not be doing what we are used to, what we expect to. Maybe we just have to think a little bit more about our answer. So what do we have here? We're trying to solve for the exact solutions. I mean, that's normally what we do. As you look down here a little further, we appear to have a less than problem. Be careful, this is not absolute value, so I don't need to split it. So yeah, it's just kind of a less than, and then over here I have a greater than. To be honest with you, the most important part of this problem is this word in between, this and. Now, we'll say more on that in a moment, but for now, why don't we just solve each of these inequalities? Like subtract 1. I'm going to, not to clutter it up, I'm going to erase that, but if you subtract 1, you just get less than -9. And then you're going to divide by -3. Okay, again, I'm going to erase that just so I don't clutter this, but if I divide by -3, now I did divide by negative, so that's going to give me a greater than. It's going to switch the sign, and then, of course, two negatives make a positive. All right, well, to be honest, there's nothing wrong with that, and there might not even seem to be anything strange with it. If I go to graph this, I think I would just be marking -3 on a number line, open circle, and shade, greater than, shade to the right. How about this guy over here? Again, we're just solving it. It's not absolute value, so I don't need to rewrite it. But if you add 5, you're just now greater than 50. And if you divide by 5, again, I'm not going to keep that there so I don't clutter this, but that's just going to be x greater than 10. Okay, well, x greater than 10 doesn't seem like that big of a deal. Just mark 10 on the number line, and oh, greater than. Okay, yeah, greater than would go this way. Now, we haven't made any mistakes, but what we do want to do is we want to clearly represent the solution. We want to clearly represent the exact solutions. And so here we go back to this word and. What we want to understand is that and implies intersection. It implies that both are happening. Can both of these be happening? Can we be greater than -3 and greater than 10? Well, yes, we can. We just have to realize that that is only going to happen where both of these regions overlap. Now, if you can see the colors, the regions are only, the regions are overlapping only in this red section. This red section where we have both the blue and yellow. You might say where we are just greater than 10. Well, yes, that is true, but what we want to realize is that I'm still greater than 3, and I'm greater than 10. So both of those are happening, again, in just the red section. Now that would be my number line. If I want to give my answer as an interval, I'm kind of running out of space on this screen, but basically my answer as an interval is going to be 10, infinity. In other words, the only space where both of these are true. Okay, now that might not have been what was expected because you're used to shaded regions coming together when you have an and statement, but these don't come together. They just overlap, and they only overlap when we're greater than 10. Now for today's assignment, the students are going to be put into groups. Since you're watching this on a video, you're probably not in a group, or maybe you just need some refresher. But let me make sure that you understand that each one of these problems, well, there's something strange about it. Now, even though there's something strange, we can still solve the problem. Normally, maybe we just need to be careful about our final answer. Maybe we just need to check our answer. So here, let's pretend we're in group 2. Okay, it's an absolute value equation. Now, absolute value equations, according to the rules, we will make the absolute value equal the positive, or in other words, the same, and we'll make the absolute value equal the negative, or the opposite. So we do split this. We get two equations. Okay, you go ahead and you do the normal routine here. You know, you're solving for x, and actually it would probably make more sense just to subtract x right here. So I'm pretty sure that's going to give you 8 equaling 2x, so x equals 4. Doesn't seem like there's anything wrong with that. What if you start solving this one? Well, you get 8, but now you get negative 4x. That means that x equals negative 2. Now remember, any absolute value problem you need to check. You need to check. So we plug in the number 4 back into the original problem, and, well, what happens? When you plug 4 back into the original problem, you get 4, the absolute value of 4 plus 8, and you get 3 times 4. Well, the absolute value of 4 plus 8 would be the absolute value of 12, and 3 times 4 is 12. So everything looks good there. Looks like it checked up. How about this other one? If we plug in, again, to the original problem, now we're going to plug in negative 2, right? So if we plug in negative 2, looks like I get the absolute value of 6, and that equals negative 6. No, that does not equal. And so for this particular problem, we simply are reminded that you have to check your answers. And after I check them, I want to appropriately cross off or circle to represent that. Let's do one more together. The truth is every one of these is a little bit different. You know, I don't want you to think that that they're wrong or that, you know, they don't work. It's just that we have to be ready perhaps for something different. I'm going to go ahead and appeal to number 3. It is another absolute value less than. Remember, less than is going to be an and statement. But even if you don't remember that, you're going to keep it. You're going to make it less than what you're given. Now, you got to be careful here because you're given a negative 4, so I have to stick with being less than negative 4. But then over here, I'm going to switch the sign. In that case, it becomes a greater than, and make it greater than the opposite. In this case, actually now greater than positive 4. Okay. Well, don't be shy about doing what you're used to doing, like solving. Both these require adding 3, but here lies the problem. When you go to graph your solution greater than 7, when you go to graph greater than 7, we all know that greater goes this way. When you go to graph less than negative 1, less than goes this way. So what's the problem? What's the strange piece here? Well, it's this word and, right? Remember, and means that it's supposed to be the intersection. It's supposed to be the common region. And your eyes aren't deceiving you. Our solutions are going in opposite direction. There's no common region. They're not intersecting. So no intersection, no and, no solution. No solution would be your final answer to this problem because there's no x values. There are no x values that are greater than 7 and less than negative 1. Honestly, if you go back to the original problem, there's no way for absolute value to be less than a negative in the first place because absolute value is not allowed to reference a negative number when it comes to distance from 0. Okay, now you need to do the rest of them. We did 2 of them together. You need to do the rest. Look out for something strange. Okay, look out for something strange. That will wrap up the activity. I guess I do want you as homework to do the problems, not I guess, but I want you to do as homework the problems at the bottom. Do not detach the paper. just do the 6 problems at the bottom for homework. They might be strange, they might not be strange. Those are just meant as a little extra practice.